Hello friends, welcome to Aravalli Geo Academy. Today we are going to discuss the next part of the Earth and its atmosphere. We have already covered the origin of atmosphere and composition of the first atmosphere and second atmosphere. And today we will discuss the composition of the today's atmosphere. Okay, composition of the today's atmosphere. This topic is very important because question will necessarily come from this topic. Okay, so in this video we will cover the present composition of our atmosphere. So there are two type of gases present in our atmosphere. One is the permanent gases and another is the variable gases. Okay, so permanent, it means the concentration of these gases are the permanent in the atmosphere, or variable, it means concentration will change with respect to time. Okay, so the first permanent gas is the nitrogen. Nitrogen concentration is the 78%, and oxygen concentration, then second abundant is the oxygen. Oxygen concentration is the 20.95%, and argon is the third most abundant permanent gas, or concentration of argon is the 0.93%. Then neon, then helium, then hydrogen, then xenon. Okay, remember this order also I will discuss, okay, in upcoming slides, the increasing and decreasing order. Then the variable gases are the water vapor. Water vapor concentration is very 0 to 4%. Okay, location to location water vapor concentration is variable. Then carbon dioxide is also variable gas because concentration is continuously increasing right now, and present concentration of the CO2 is 0.041%. Okay, or in also remember in the ppm the concentration of the carbon dioxide is 410 ppm. Okay, around. Then third most abundant variable gas is the methane, CH4. Okay, then nitrous oxide, N2O, then ozone, then particulate dust or soot. Okay, chlorofluorocarbon or hydrofluorocarbon. Okay, so remember separately which one is the variable gases and which one is the permanent gases and concentration. Okay, let's discuss through the detail. So see the permanent gases: nitrogen, oxygen, argon, neon, helium, hydrogen, and xenon. Okay, remember helium is greater than hydrogen in the present time. Okay, helium is the greater than hydrogen in present time, and neon is greater than helium, hydrogen, and xenon. Xenon is less than the all. Okay, and variable gases are there. Okay, so see first this one, the permanent gases. This is the increasing order: xenon, then hydrogen, then helium, then neon, then argon, then oxygen, and nitrogen. Okay, then decreasing order: nitrogen, oxygen, argon, neon, helium, hydrogen, and xenon. Okay, and these are the variable gases. Water vapor is variable, and carbon dioxide, methane, nitrous oxide, ozone, particulate matter, or chlorofluorocarbon or hydrochlorofluorocarbon. Okay, so see first the increasing order: CFC or HFC, then particulate matter or ozone, nitrous oxide, methane, carbon dioxide, then water, or this one is the decreasing order. Okay, so remember this. Okay, try to take a screenshot of this slide and write the notes. Okay, of increasing or decreasing order. Okay, this is very important for this lecture. Okay, in this lecture this slide is most important. Okay, questions come from this slide in CSIR-NET or other other exams like GSI prelims, etc. Now we already know the nitrogen make the 78% part of our atmosphere, and oxygen is 21% part of our atmosphere. Okay, so this concentration of the 78% and 28% is actually constant up to 80 kilometer. It means from surface to 80 kilometer the concentration of the gases is the constant. Like in the stratosphere, the composition of the nitrogen and oxygen is 78 and 21%. Then stratosphere is also nitrogen is 78 and 21. Then mesosphere also having the nitrogen concentration 78 and 21%. If examiner directly asks you what is the concentration or which gas is dominant in the stratosphere, then your answer will be nitrogen, because this concentration is constant up to 80 kilometer. So examiner directly give you any height or ask you which gas is dominant or which gas is less dominant. So remember this concentration. Okay. So next, uh, there is a balance. Okay, in our atmosphere there is a balance, the input and output of the gases. Okay, atmospheric gases, like the first we discuss the removal process of the nitrogen, how to nitrogen remove from the atmosphere. So nitrogen remove through the biological process. Okay, soil bacteria involve this biological process, because soil bacteria convert nitrogen into nitrogen compound, and after that plants use these nitrogen compounds are forming the nutrients. Okay. As well as phytoplanktons also take nitrogen and convert into the nutrients. Okay. So nitrogen is actually removing through this process from atmosphere. Okay. So remember both the points, how to remove nitrogen from the atmosphere. Then how to add nitrogen in atmosphere? Nitrogen return to the atmosphere through the decay of the plant and animal. After the death of the plant, we already know plant having the nutrient, and the actually animal also having nutrient. So these nutrient, after the decay of these nutrient, okay, nitrogen again return into the atmosphere. Okay. Then we discuss about the oxygen, how oxygen remove from atmosphere. So oxygen is removed when organic matter decay. Okay, from the oxides. After the decaying of the organic matter, oxygen is required. Okay, for decay oxygen is required. So oxygen removed from the atmosphere through the organic decay. Okay. And how to add? Okay, breathe, actually breathing also remove the oxygen, because we are using actually through the breathing we are using the oxygen now. So oxygen continuously remove from atmosphere now, and we are adding the carbon dioxide into the atmosphere. Okay. So remember the both, the removal of the oxygen from the atmosphere, removal process of oxygen from the atmosphere. Okay. Oxygen removed through the organic decay, or as well as the through the breathing process. Okay. Then how to oxygen added in the atmosphere? Oxygen added through the process of the photosynthesis. We already know through the photosynthesis plant actually make sugar and CO2. So oxygen continuously added into atmosphere through the process of photosynthesis. Now we discuss about the water vapor. So water vapor concentration vary location to location. Okay, location and time. We already know water is a variable gas, and concentration of water vary from 0 to 4% now. So water vapor concentration vary location to location. It can reach up 4% in the warm tropical area. Okay, in the humid area or near to equator area, water vapor concentration is highest, up to 4%. Okay. Or in actually cold or dry area, water vapor concentration is less than 1%, because in the cold area this is water vapor is not, because this is the dry region. So water vapor concentration is less than 1 in the polar region, and water vapor concentration maximum in the actually equatorial or humid or tropical region. Okay. Water vapor is the invisible gas in the gaseous state. Remember this factual point. Water vapor is invisible in the gaseous state. Okay, and water vapor visible in after the condensation of the droplet or ice, because water vapor visible when it's condensed into the droplet or ice. Condense, it means condensation. Okay, condensation is a process in which water vapor convert into the liquid. Remember this factual point. Okay, what is the condensation? Condensation is a process in which water vapor convert into the liquids. Okay, condensation is the change of the vapor to the liquid, and evaporation is change from the liquid to the vapor. Okay, just the opposite. Now rain and snow falling from the cloud is called precipitation. So what is the precipitation? Rain and snow falling from the cloud, this is known as the precipitation. Okay, then water exists as a gas, liquid and solid. Water exists in the both three form of phases. Okay, gas as well as liquid and solid. Okay, and water concentration maximum in the lower atmosphere. When we move from surface to upward, then water concentration is continuously decreased. Okay, remember this one also. Water vapor is a crucial gas in atmosphere because actually water, without water vapor there is no weather phenomena. Okay, water vapor form the clouds. Okay, and cloud leads to the precipitation. Okay, or rainfall. Water vapor condense, it's release latent heat. So first I tell you about the latent heat. What is the latent heat? Okay, listen, uh, assume first, just wait. Okay, first this is the water. Okay, so water convert into the vapor. Okay, and vapor condense into the water. Okay, then this water convert into the ice. Okay, something. So water change phase, this is the water and this is the vapor. Okay, so water convert into the vapor, then vapor to liquid, then liquid to actually solid. Okay, so during the phase change, water absorb or remove the actually energy, because when we provide the heat to water, then water convert into the vapor. Okay, then vapor release the energy and convert into the water. Okay, then again water release the energy and convert into the ice. Okay, so this absorbing and releasing energy is known as the latent heat. Okay, so when water condense, it is release the latent heat. Okay, because we provide the heat to the water, then water convert into the vapor. So this vapor having this heat. Okay, so this heat release after the conversion of vapor to water. Okay, vapor to liquid. So this heat is known as the latent heat. Okay, now next, this latent heat actually work as a fuel for the storm or thunderstorm and hurricane. Okay, remember this point. What is the fuel of the thunderstorm and hurricane? Latent heat. Okay, latent heat actually released during the phase change of the water. Water vapor is a strong greenhouse gas. Remember this point also. Water vapor is the greenhouse gas. CO2 is also greenhouse gas. This water vapor absorb as the outgoing radiant energy, because greenhouse gases absorb the outgoing radiant energy of the earth, and this absorbing energy trap the heat near the earth surface, or due to the trapping of this heat, temperature is continuously increasing. Okay, and this effect is known as greenhouse effect. Okay, due to greenhouse effect, temperature of the our earth is continuously increasing, and this water vapor helps them maintain the earth heat energy balance. Okay, this is balance the temperature. So thank you so much for watching this video. Try to share with your friends, those are preparing for the CSIR-NET or SET exam, as well as the GSI combined geoscientist exam. So try to share with your maximum friends, or if you have any doubt, then drop a message in the comment section. Thank you.